What we're going to do is we're going to look at functional operations and characteristics of graphs. So we have two different functions. We have f of x equals 2x minus 1. We also have g of x equals 3x plus 7. So what we're going to do is we're going to simplify following the different operations. So for the first one, we're adding the two different expressions. So we're going to add the 2x minus 1. That would be our f of x. Then what we're going to do is we're going to add the 3x plus 7. That right there is coming from g of x. So when we add the like terms, 2x plus 3x is 5x. Negative 1 plus 7 gives us 6. And that's our answer. For the next one, we're subtracting. So we set it up the same way. We have the 2x minus 1. That's our f of x. This time we're going to subtract, and we're going to subtract the g of x, which is 3x plus 7. When we subtract it, what I like to do is distribute the negative. So I have 2x minus 1 minus 3x minus 7. So when I add the like terms, I have the 2x minus the 3x, which gives me negative x. I have the negative 1 and the negative 7, which gives me negative 8. Now for letter C, this time what I'm going to do is I'm going to multiply the two. So when I multiply the two, I'm going to take the 2x minus 1, and I'm going to take the 3x plus 7. And since I'm multiplying, I'm going to FOIL it. So I have 2x times 3x, which is 6x squared. I have the 2x times 7, which gives me 14x. I have the negative 1 times 3, which is negative 3x. And the negative 1 times 7, which is negative 7. When I add the like terms, I have 6x squared. These two are like terms, so that gives me plus 11x minus 7, and that is my answer. Now, looking at the next ones, these are composite functions. With the composite function, it means we're plugging a function into a function. We always start in the middle. So with this first one, what we have is we have 5, and we're going to plug that into our g equation. So g of 5 is equal to, I'm going to take my g, which is the 3, but instead of an x, I'm going to put a 5 and then plus 7. 3 times 5 is 15, plus 7 gives me 22. So now that this is 22, I'm going to plug it into my f equation. So I'm finding f of 22. So I have 2 times 22 minus 1. 2 times 22 is 44, minus 1 is 43, and that's going to be my final answer. Now for the next one, I have the g of x. This time I don't have a number, so what I'm going to do is I'm going to take my g expression and I'm going to plug it into my f expression. So when I plug it in, I'm going to plug it in for the x. So my f is 2, but instead of an x, what I'm going to replace it with is a 3x plus 7. I'm going to distribute the 2. So I get 6x plus 14 minus 1, which is 6x plus 13. Now, looking at letter F, this time I'm going to start in the middle, and I'm going to take my f equation, and I'm going to plug it into my g equation. So when I do this, I take my 2x minus 1, and I'm going to plug it into g. So I have the 3, but instead of an x, what I'm going to do is I'm going to put in the 2x minus 1. So I distribute the 3, 6x minus 3 plus 7, and that right there gives me 6x plus 4. Now, for the next example, what we have is a graph, and we're trying to find the key characteristics. First thing I notice about the graph is it has arrows. So when I'm finding the domain, it tells me that it goes to the left and it goes to the right. So that would be negative infinity to infinity. For the range, I notice that my lowest is -2, and it keeps on going up. So that means that I'm going to put a bracket at -2 because it includes the -2, and then it keeps on going to infinity. The reason that it's a parenthesis is that we never get to infinity. Now, when I'm finding the roots would be the x-intercept. So I have -3, 0, and I have 1, 0. Next thing I'm going to do is find my y-intercept. Y-intercept is where it crosses the y-axis, which is at -1. So I have 0, -1. Now the maximum is the highest value. Since it keeps on going up, there would be no maximum. The minimum we actually have. If we look at our graph, we see that we have a lowest point. And we're going to write the ordered pair, -1 and -2. And is it a function? Well, we're going to do the vertical line test. We draw a vertical line, and if the vertical line only crosses it once, then that means that it is a function. So yes, this is a function. An example of something that wouldn't be a function would be like a circle. If we had a circle and we were to draw a vertical line, we see that it crosses twice, and that would be not a function. In this case, it only crosses once. In each of those cases, that's why it's a function.